Good morning, this is Kavi Priya, Assistant Professor, EC Department, SNS College of Technology. I am going to discuss about the topic group velocity from the subject electromagnetic fields and waves. And this is my flow of presentation. I am going to discuss about what is this group velocity and its importance, and what is the comparison between the phase and the group velocity, what is a mathematical expression for this group velocity, then the relationship between this Vp and Vg, which is nothing but phase and group velocity, and what is the value for this Vp and Vg, how far this Vp and Vg will be there for anomalous dispersion and normal dispersion, and finally about the applications of this group velocity. So first, what is this group velocity? So what is the importance of this group velocity? So through this group velocity, we can determine what is the propagation of the wave packets. And this group velocity is very much important in the communication and signal transmission. So this group velocity is nothing but it is a speed at which the energy or information travels. So we will be representing this group velocity as V suffix g. So Vg is equal to d omega by d beta. So we all know omega is an angular frequency and beta is a propagation constant. So the differentiation of this omega with respect to beta give rise to the group velocity. And next, what is the expression for this phase velocity? So phase velocity is represented as Vp, which is nothing but it is a omega by beta, whereas group velocity is represented as Vg, which is nothing but d omega by d beta. So both this phase velocity and group velocity will be equal in the non-dispersive medium. And next one is what is the relationship between this Vp and Vg, and before that what is the expression for this Vp with respect to Vg or Vg with respect to Vp. So initially we have an expression for this Vg, which is nothing but d omega by d beta. So what is the expression for Vg in terms of Vp? So Vg is equal to Vp minus lambda into dVp by d lambda. So lambda is a wavelength. So this Vg is defined as the rate of change of angular frequency with respect to the propagation constant beta. So this Vg can be expressed in terms of Vp as well. So the second equation Vg is equal to Vp minus lambda into dVp by d lambda is a relationship between this Vg and Vp. Next one, what is this wave packets? So this a group of waves with different frequencies, we call it as a wave packets. So the envelope of the wave will be containing the actual information. So the envelope moves with group velocity. So this envelope carries the information and the velocity of this envelope is same as the group velocity. So the envelope is one which carries the information. Next, what is the relationship between Vp and Vg in terms of c, speed of light? So Vg star Vp is equal to c square in some medium. So that value will be depends on the medium properties. So group velocity is nothing but it is a speed of wave propagation, wave packet propagation, and the phase velocity is a speed of wave crest propagation. And what is this normal and anomalous dispersion? So in case of normal dispersion, this Vg group velocity will always be less than the phase velocity. So Vg will be less than Vp. In case of anomalous dispersion, this Vg will be greater than Vp. So this group velocity will be greater than the phase velocity. So this understanding this normal and anomalous dispersion is very important in the electromagnetic waves and optical communication. Finally, what are all the applications of this group velocity? So by determining the group velocity, we can determine what is the signal speed. And second one, through this group velocity, we can analyze what is the distortion that has happened in the wave, and what is the degradation happened in the wave, and what is the data integrity happens in the wave. It can be easily estimated using this group velocity, and it is very much important in high speed communication. It is one which maintains a clarity and speed in case of the modern communication. And this is the summary of what I have presented so far. I have discussed about what is this group velocity, what is the expression, what is the relationship between phase and group velocity, what is an expression for this group velocity, and what is the expression for phase velocity, how far this Vp and Vg are being get related, and what is this normal dispersion and anomalous dispersion, what is the value of this Vp and Vg in case of normal and anomalous dispersion, and we have discussed about this wave packet concept as well. And finally, the applications of this group velocity. And these are all my references. Thank you.